Good morning all. Hope you all are doing good. Today we'll be doing chapter number 4, Basic Geometrical Ideas of class 6 from Learn Forward Feather Cap. Before starting up with the different concepts of basic geometrical ideas, let us see the different images that are shown in our chapter. First is the road signboard, right? It is the board that represents do not enter in this area. So what is the shape of this signboard? It's triangle. Great. What is the shape of the top of the sandwich? It's again triangle. What is the shape of the Dairy Milk chocolate? It's a rectangle. If I talk about the Indian flag, the border of Indian flag is again rectangle. If I talk about the marigold biscuit, it's circular in shape. But if I talk about the globe, earth, it's not circle, it's spherical in shape, because globe is a 3D image. Fine. So in this particular chapter, we'll be learning about different shapes, different concepts that are included in our geometry. Fine. We'll be starting up with the first concept, that is point. Okay. If I ask you to write down your name, what will be the first thing that you will be doing? You will be picking up your pen or pencil and pointing it on a paper, right? Before writing your name initial also, you will be first drawing a dot, right? This dot means the point, right? After that, we will be able to start writing. If my name is Piyush, what I will be writing? P-I-Y-U-S-H, right? But when I started to write my name, I started up with the point. So whenever we start drawing something, we start with a point. So point have no size because it's such a small thing that it cannot be measured. So point have no size, no dimension. It has no dimension. Can you measure the point? That point is so big or so small? No. Point is just a dot that it cannot be measured. That's why point has no dimension. It has no width, no length, no height. Fine. For example, you are here. Let's suppose your name is Rajat, and Rajat wants to go to his friend Suraj's house. He'll start with the point A and will reach till point B. So point represent a specific position. Fine. Now the second concept is line. Second concept is line. Whenever we join any 2 points, let's suppose you are here. Okay, we can see here only. If Rajat wants to go to the house of Suraj, he will follow this path. This straight line is called line segment. Sorry, it's called line. Why line? Because it can be extended in both the directions. Whenever a line can be extended in both the direction, it is called a line. Okay, it has a length, so its dimension is 1. It's one dimensional because we can always measure the line. You can notice the arrows are given at both the ends. That means AB is a line which can be extended in both the directions. Second point. Sorry, third one is line segment. Now if I talk about this pen, can you stretch this pen in any of the direction? The answer is no. It has a specific length, right? If I take a scale and measure it, I would say it's somewhere around 15 centimeter. So it's a segment. Segment means part of something. When we take AB as a part of this line, it has a specific distance, right? So when line cannot be extended in any direction, it is called line segment. Fine. So AB here is a line segment. There is no arrow at any end of any point. Fine. Next concept. Okay, a line segment is named by its 2 points with a line segment symbol. Okay, how do we write AB? AB is a line segment by drawing a line segment on the top of it. If I talk about the line, how we represent line? AB is a line, but it's a line, so I'll put arrow on both the ends. Fine. AB is a line by putting arrows on both the sides, and if there is no arrow, that means it's a line segment. Fine. Now, third one is various types of lines. Types of lines means parallel lines. What are parallel lines now? Lines which do not intersect. Intersect means cross each other or meet each other, right? The lines, the pair of lines which do not intersect each other, do not meet each other, even if they are extended. Even if I extend both the lines to the infinity, they will not intersect. The best example is railway tracks, right? Whenever you see a railway track, it goes straight, both the lines go straight. It will never happen that one line will go there and one line will keep on taking straight path. No, they will go parallel to each other, they will never intersect each other. Other than this, one more example is ladder. You must have played Ludo, right? Not Ludo, snake and ladder game, right? You must have played snake and ladder game. In that, this is the ladder. So in ladder, what happens? These two lines, this one and this one, these two lines are always parallel, right? So in ladder also the opposite sides are parallel. In railway track also the two lines are parallel. They do not meet each other. How do we write it? Line AB is parallel to line CD. Line AB. How do I know it's a line? Because there is arrow on both the ends. Parallel. This is the sign of parallel. What we have written? AB line by putting arrow parallel to line CD. Got it? So parallel line is written in this way. Okay, we can further read it out. Okay. Intersecting lines. Next concept is intersecting line. I have already told you what are intersecting lines. The lines which cut each other or meet each other at any point. Here you can see line AB and CD are crossing each other, right? And they are meeting at point E. Therefore, we will say intersecting are the lines in the same plane. In the same plane means they are drawn in the same page, you can say, that meet and pass through one another at one point. They will intersect at only one point. AB intersect CD. AB line intersect CD at point E. Quite easy. Can you give me the example of any, think of any example where you can say these are the intersecting lines? Jesus cross, right? You must have seen a Jesus cross. Its sign is something like this. It's a plus. So these are the intersecting lines. Or you can say road traffic. Whenever you go on the roads, there is, we call word in chauraha, right? That means four-way road. Now we come to the next concept, ray. Now if I have a torch in my hand and if I switch on it, right, switch it on, then it will make the light travel in one direction. If I switch on the torch like this, the light will not come in my direction but will come towards you. So ray, it starts with a point and only travels in one direction. Ray always goes in one direction, right? So ray is starting from A and going toward B. I will not say to B, no, toward B, because it can be extended to infinity, right? So a ray is also a part of a line that extends infinitely in one direction only. Here A is called the initial point. A is called the initial point because ray is starting from that particular point. So we represent AB. And how many rays can come from a single point? Infinite lines. Like you can see over here from A, 1, 2, 3, 4, 5, 6, and there are so many lines which are passing through this particular point. Fine. Now, but a ray is completely known if its initial point and one more point on it are known as shown here. What do we say? This ray has started from A and going toward B. Now this is the exercise. Till now what we have covered what is point, what is line segment, and what is ray, right? And what are parallel lines and what are intersecting lines. So these are the concepts we have covered. Name the points shown in the figure below and join them in order. Okay, so I'm naming it as, why don't I write my name only? I'm writing P I Y U S H. I've given my name to these points, Piyush, and I'm joining these lines 1 2 3 4 5 6. So I have given the points their name and I have joined it. Fine. Write the name of the line in the following figures. Write down the name of the lines. So can you name any or think of any line over here? PQ is extending in both the direction. You can notice these arrows pointing in toward both the direction. So what would I say? PQ is a line. Also PR is line. Also QR is line. So these are the three lines in this figure. You can find out the another one, do it yourself. Name the initial point of the following ray. Now you need to be very careful while thinking of the ray. If I write ray is PQ, that means ray is starting from P and going toward Q. Okay? And if I say QP, that means ray is starting from Q and going toward P. So there is an initial point, there is another point in which the rays is going. Name all the rays shown in the figure given below. I guess you will be able to do these questions. Let's do the fill-ups. A point has no dash and dash. A point has no size because it's the smallest part, and it has no dimension. A line segment has length. A line segment has a specific length, a definite length. Because it's a segment, it's measurable. Ray has only dash end point. Ray has only one end point. Because this is the end point, this is not going in this direction. It do not have another end point because it's keep on going till infinity. So there is no end, there is only one end point. Two distinct lines can intersect at dash points. Two intersecting line can only intersect at one point. So this is the way we have done the fill-ups also. I believe rest of the question you can do it by yourself. Fine. So we are continuing with the next concept, that is curves. Now what are curves? Think of anything which has a curve in it. Okay, there can be some roads also which are curvy in nature. They are not straight but they are a bit curvy. Okay. When you think of chapati, right? It's not a square shape or rectangle shape. It's curved. It's have a circular line, right? So let us read the definition of curve. In our daily life, we observe many pictures which represent an example of curve. In mathematics, a curve is an object similar to line but is not required to be straight. Curve is anything which is not necessarily to be the straight line. It can be, it cannot be a straight line. The pictures that are results of your doodling are called curves. What is doodling? Whenever you get bored and you just start drawing the random lines this way, this is called doodling. This is the curve. Fine. Now the second concept, the type of curve, is simple curve. Simple curve is that curve which do not intersect itself. This is the curve. It's not intersecting itself. But if I say now this curve is intersecting itself at a 2 point. One is this, another is this. When the curve do not intersect itself, we call it a simple curve. Fine. Example are drawn over here. But when we say closed, okay. wait a minute. Okay. Next is, okay, next category is not mentioned over here. Against the simple curve, what do we write? Complex curve. This is the simple curve, and when the curve intersect itself at any point, it's called complex curve. You can write it down. It's not mentioned over here. So when a curve does not intersect, it's a simple curve. When the curve intersect itself, it's called complex curve. Fine. Now next is the open curve. What is open curve? When the starting and ending points are different. When the starting and ending points are different, we call it a open curve. I have drawn a random curve. Its starting point is this, ending point is this. Imagine it to be a thread, right? If it is a thread, what I can do? I can just stretch it out, right? It will form a straight line. Then if a curve can open into a straight line, it is called to be a open curve. You can see the examples over here. Starting ending point are different, starting ending point are different, starting ending point again are different in all the curves. Now closed curve. Now the curves, when there is no ending or starting point, you are unable to find out the starting or ending point because it's a closed path, right? So whenever you go for a jogging or you roam around in the park, right, on a foot on the corner of the park, when you go for the morning walk, right, you just start from a point, you keep on walking. It's a closed curve because there is no start or ending point. There is no start or ending point I can find in these images. Now it is called closed curve. Also you can imagine in that way that there is no way to enter in these curves. There is no door to it. You cannot enter in these curves. These are closed one. You cannot enter. But when we talk about these curves, you can enter. You can go inside. In each curve, you will be able to go inside. It's an open curve. It's a closed curve. Which do not intersect, simple curve. Which intersect, it's a complex curve. Fine. Position in a figure. Have you played a game, board and dart game, right? Where you need to score by pointing a dart on the board, right? This will give you 50 points. This will give you 100 points. Okay, this will give you 500, this will 100, and this is 10 points. When you throw a dart and it strike over here, it is interior. Your dart goes interior of this image, it's called interior point, right? If it's on the boundary, then what do we call? It is boundary of the curve. Your dart has reached the boundary. But if you have missed the aim and it goes somewhere here, then this is exterior of curve. Fine. Any point which is inside, as you can see in this image, name a point which is inside the curve. Point A, right? Name the point which is on the boundary. Then there are 2 points, B and C. Name a point which is exterior of curve, which is outside the curve, is point D. So this is quite simple, right? Next is polygon. Now what are polygons? A polygon is a simple closed curve made up of a line segment. Simple means it will not intersect. Closed means it is a closed, you can't go inside, and it is made up of straight lines. Fine. Imagine your carom board, chess board, pizza slice, right? So these are the examples of simple closed curve made up of line segment. Sorry, pizza slice is not an example because it has a curve. It's called polygon. Can you draw any closed curve by 2 lines? Is it possible to draw a closed curve using 2 lines? No, not possible for me. Try it out yourself. Is it possible to draw closed figure using two straight lines? It's not possible, because we need at least three lines to make a polygon. So the smallest polygon which is possible is triangle, right? The four-sided figure we called a quadrilateral. Now this polygon has 1, 2, 3, 4, 5, 6, 7, 8. 8 lines. It's a octagon, right? These are the names some of you must be knowing. Now these are the simple closed. The line is not intersecting in any of the figure. They all are closed. You can't enter these curves, and they are made of straight lines. So these are the example of polygons. Fine. Next is the sides. Okay. So okay. So I am drawing a polygon over here. And I am naming it as A, B, C, D, E. This is the closed polygon made up of straight lines, and I am named it A, B, C, D, E. First concept is, what are sides? Side of polygon. This is the side. This is the side. So this is the first side. So side will be side AB. Okay, this has been already drawn over here. Side AB, then side BC, then side CD, then side DE, and at last side AE. So this figure is having exactly 5 sides. Fine. Vertex. Now vertex. What are vertex? Vertex are the points, the meeting point of a pair of sides. Whenever two sides come together and meet at one point, these points are called vertex. You must have played Ringa Ringa Roses with your friends, right? And some of you might be playing these days also. Okay. So whenever you join your hands with your friends, your hands are line segment. That means they are sides. But you as a point, you are a vertex, right? Imagine A, B, C, D, E are 5 friends. They are playing Ringa Ringa Roses. So their hands is called side. They themselves will be the vertex. Fine. Next, adjacent side. I am again drawing that figure only. A, B, C, D, E. Fine. Now what are adjacent sides? You already know what are sides. So adjacent means neighbor. Adjacent means your neighbor. If I say AB is a line segment, it's a side. Who is closest to AB? Who is the neighbor of AB? AB has a neighbor BC. BC is the neighbor. So what I can write, AB comma BC in a one bracket, so that we can see AB and BC are neighbor. They are adjacent side. Now BC is the neighbor of CD. So I can write BC comma CD. Now CD is the neighbor of ED. CD is the neighbor of DE. And DE is the neighbor of AE. DE is the neighbor of AE. Also AE is the neighbor of AB. So in 5-sided figure, how many adjacent sides are there? 1, 2, 3, 4 and 5. Clear? I hope this concept is clear to you. Next is adjacent vertex. Now adjacent means padosi, neighbors. Vertex means a point. So who is the neighbor of A? Who is the neighbor of A? We can say A is a neighbor of B. So how we will write? A comma B. Now B is the neighbor of C. So how will we write? B comma C. Similarly, C is the neighbor of D. D is the neighbor of E, and E is the neighbor of A. So again we have 5 pairs where we can say these are adjacent vertices. I hope this is also clear to you. Now comes the diagonals. Now what are diagonals? The non-neighbor vertices. When non-neighbor vertex, what I want to say, non-adjacent vertex A and C, they are not neighbors, right? They are very far toward each other because B is there in between. When A and C, these are not neighbors, join their hands. What I have done? I have drawn a line from A to C. I have joined A and C non-adjacent vertices by drawing a line. So this is the diagonal. What would I say? A and C are non-neighbors, non-adjacent, and I have drawn a line by joining them. So what would I say? AC is a diagonal. Okay. A is diagonal to D also. So what can I write? AD is also a diagonal. Okay. AE are neighbors. Coming to B. B is not a neighbor of D. So BD is also a diagonal. BE is also a diagonal. Right? Coming to C. CE is also a diagonal. Fine. You can read the definition as well. The joints of the pair of vertices which are not adjacent. When we join two non-adjacent vertices, they form a diagonal. I hope this concept is clear to you. In this particular, we have learned about what are curves, what are simple curves, what are complex curve, what are closed curve, what are open curve. Then interior of the curve, boundary of the curve, and exterior of the curve. Then we have read about the polygons, sides of polygon, vertex of polygon, adjacent sides, adjacent vertices, and diagonals. I hope the concepts are clear to you. Now we'll do some questions of this exercise. Identify the curve as open or closed. A part, is it open or closed? It's open because it has a starting and ending point. And also I can enter here, so it's a open curve. B is a closed curve because I cannot enter in B. C is again open curve. D again closed curve. E again closed curve, and F open curve. I hope you are able to do it. Okay. Second question we have already done. You can do it by yourself. Write the points which lie on the boundary, interior and exterior. I hope the concept is clear to you and you will be able to do both the parts. That's all for the exercise of this particular concept. Now our last concept in this chapter are angles. Now what are angles? What are angles? Okay. So angles are formed by two rays with a common end point called vertex. I have given you the example of torch, right? Whenever I switch on the torch, its light will start from here and it will go in multiple directions, right? Rays, angles. Now how we define the angle? When two lines coming out from a single point, when two lines are coming out from the single point, I am taking these two lines. Two lines coming out from a single point. This point we called a vertex. This is the angle. Have you seen the crocodile face? Right? When I believe the crocodile will never come to you, close to you. If you see the crocodile face, when he does not open his mouth, it's a 0-degree angle because it's not open yet. He might open its mouth this much or this much or this much or this much. So this is the angle he is forming. Fine. So we can remember the angles by crocodile mouth. How much mouth he is opening is called the angle. Fine. Here you can see angle AOB. A and B are the points in which the ray is going. O is called the vertex and this is the arc angle, or you can say angle. Fine. Also, okay, so I am drawing over here this point where the ray is starting is called vertex. What it's called? Vertex. I have given it a name O. If it's going toward the point A and point B, so these are the arms or side of the angle. Arm is OA, OA is one arm and OB is one arm. OA and OB are arms. But since these are rays, we will draw arrows that represents the ray is starting from O and going toward A. Fine. And the opening is called angle, or you can say arc angle. Okay. Naming of angle. How do we name the angle? We start with any of the point in which the ray is going. We can write A, O, B. See, whenever you take a turn, this is the midpoint. You start with A, O and take a turn B. P, O, Q. Okay. So how do we name the angle? Either you can write A, O, B. This is the angle, sign of angle. How do we draw the angle? Anything like this. Then A, O, B, or we can say B, O, A. Again angle B, O, A. Both are same thing. You go AOB or BOA, it doesn't matter. It's the same thing only. The angle will remain same. Or you can write angle O as well. Or you can write angle O as well. Fine. So these are the three names. Example 1. Name the vertex arms of the following angle. If I name the vertex, so what is the vertex over here in figure A? A is the vertex because it's the starting point of the ray. What are the arms? AB and AC are the arms. So that was quite simple, I believe. Interior and exterior of angle. Interior and exterior. Now, if it is the angle over here, you can see I have already drawn the angle. And if I close it like this given in the image, any point which is lying inside this angle is called interior. And if the point is lying outside it, it's called exterior. And if it is on the angle, we will say the point is on the angle. Fine. Interior, exterior and on the angle. So we are done with the concept of angles. Give 3 examples of angles from your environment. You can look around in your room as well. You can, or you will be able to find some of the things where you will be able to notice the angles. Fine. Name a vertex and arm, that we have already done. Draw angle. Now you need to draw the angles. CBD. I am doing one part for you. We'll start with C, go with B and turn D. Now C, B, D. Make sure whichever alphabet is in the middle is the vertex point. So this is our angle CBD. Fine. How many angles are shown in the given figure? Name them. Okay. So this is the quite interesting question we have. Now if you see, you will be able to say that there are 3 angles, DOC, COB and BOA. Right. These are the clear angles that we can see. Angle DOC, angle COB and angle BOA. These are the 3 clearly angles that we can see. But there are some hidden angles as well. I can write DOB. This is also angle. Right? So angle DOB. Also there is COA. So I will write COA. Also there is DOA, this whole angle. So how many angles are there? 6. DOC, COB, BOA, DOB, COA and DOA. These are the angles, 6 angles this image has. Fine. In the adjoining figure, name the points which are in interior of angle POQ. That you can do by yourself, which are the interior, exterior and on the boundary. Second, point B is in the, okay, you need to find out the figure. In adjoining figure is point B is in the interior of A or B. Okay, so we need to say yes or no, true or false, that you can do by yourself. Now we are done with the chapter basic geometrical ideas. Hope you have understood all the concept. Do the practice well by yourself. You can solve them out easily. If you have not understood anything, you can rewatch the video again. Thanks, take care, bye-bye, and make sure you learn and study well. Happy learning. Take care. Bye-bye.